Welcome to AP Calc, Lesson 10, Logarithmic Differentiation. And it sounds scary, and it is. But it's a great way of finding the derivative of a very, very complex functions. And it will help us to make it easier to do, because otherwise it would be insanely impossible. We're going to use what we learned yesterday about the derivative of natural logarithms, and then play around with that a little bit to use logarithmic differentiation. So let's go ahead and move on. Okay. Yesterday we found the derivative of the natural logarithm of any function of x to be equal to g prime of x all over g of x. Right? We learned that yesterday. So if I cross multiply, or if I multiply both sides by g of x, I'm going to get g prime of x on the right side, and on the left side I'm going to have g of x times the derivative of the ln of g of x. Those two expressions are going to be equal. And this right here is what logarithmic differentiation is all about. What we're going to do is we're going to look at some function g of x, which is ridiculous. We'll take the natural logarithm of it, use the properties of natural logarithms, then take the derivative and then multiply by the original, and that's what the derivative is going to be. You're like, what? Here, let's put this into practice. Okay, imagine that you had to take the derivative of g of x. Here's our first function. We'll call it a. That's our first function of x. Here's our second function of x, b. And then here's our third function of x. We'll call it c. Okay, in order for us to take the derivative of this, we would need to use the product rule and the chain rule and all kinds of crazy things. G prime of x. Alright, we're going to take the derivative of these first two. Yeah, I don't even want to start. I don't even want to think about it. That is so crazy insane to try to use the product rule on three things. I think it'd be a lot easier to use logarithmic differentiation. And this is how it's going to work. We're going to take the ln of g of x. That's going to equal the ln of 2x minus 3 to the fourth power times 5x minus 6 to the seventh power times 8x minus 9 to the 10th power. So we can simplify that. We can say that that is the ln of 2x minus 3 to the fourth power plus the ln of 5x plus 6 raised to the seventh power plus the ln of 8x minus 9 to the 10th power. Okay, now we can deal with those exponents. 4 ln of 2x minus 3 plus 7 ln of 5x plus 6 plus 10 ln of 8x minus 9. So that's what the ln of g of x is. Now we got to take the derivative of that. Take the derivative of this. And that is going to equal 4 times the derivative 2 over 2x minus 3 plus 7 times 5 over 5x plus 6 plus 10 times 8 all over 8x minus 9. Okay, there's the derivative of the logarithm. What do we need to multiply that by? The derivative of the logarithm times the original function. So, whoops, I moved one too far ahead. So we're going to take this right here and we're going to multiply it by 2x minus 3 raised to the 4th power times 5x minus 6 to the 7th power. Multiply that times 8x minus 9 to the 10th power. And there is g prime of x. Wow! And guess what? I'm not going to make you multiply this out, at least not today anyway. And that's the derivative of g of x. Let's go ahead and try another one. What do you think? Oh, wow. Could you imagine taking the derivative of the numerator, multiplying it by the denominator, then subtracting the numerator from the derivative of the denominator all over this denominator squared? Good. Neither can I. Take the natural log of both sides, and then you're going to have the ln of sine x minus 2 cotangent x, all that raised to the 4th power, plus the ln of 3x to the 6 minus 4x to the 7 halves, plus 6 raised to the 9th power, minus 4x to the 5th minus 6x squared plus 8 raised to the 1/2 power, and this should be the ln of that expression. Move the exponent out front. 4 times the ln of sine x minus 2 cotangent x plus 9 ln 3x to the 6 minus 4x to the 7 halves plus 6 minus 1/2 times the ln of 4x to the 5th minus 6x squared plus 8. Whew. Okay, there's the natural log of g of x. Now we're going to take the derivative. I'm going to pause it or I'll run out of room. I'm going to pause this and let you work on finding the derivatives of this expression. And then once we get that derivative, we'll multiply by the original. Alright, so I'll be back in a couple seconds. Spend some time working on this, okay? Okay, there's the derivative of that set of natural logs. Whew. Okay, and according to our definition of logarithmic differentiation, we're going to take this and we're going to multiply that right here, the derivative of the natural logarithm. We're going to multiply all of that by g of x. So 7/2. Okay, all over. I don't want to rewrite this all over again, okay? That's what I'm doing. There you go. We're going to multiply those two things together. The derivative of the natural logarithm of g of x times g of x, and that's the derivative. I can't imagine doing it the other way. That would be insane. Now here comes your last example, I do believe. G of x equals x sine x. Okay, take the natural log of both sides. The ln of g of x equals the ln of x sine x. Whoops, sorry. X to the sine x power. So that equals, we can use that, move that exponent down, sine of x times ln of x. That's what the ln of g of x is. Okay, so let's go ahead and take the derivative of that, both sides. Derivative of both sides, that would equal, let's see here, product rule, two functions of x. So you've got derivative of the first one times the second one plus the first one times the derivative of the second one so that we can clean that up a little bit. Cosine of x ln of x plus sine of x over x. There's the derivative of the natural logarithm. Now we need to multiply both sides by g of x. So g prime of x will end up equaling cosine of x ln of x plus sine x over x. Multiply that whole thing by x to the sine x. And that would be the derivative of x sine x. Whew. This will conclude AP Calculus Lesson 10, Logarithmic Differentiation.